What if I told you your network is one big messy party where everyone hears everything? Without VLANs, that's exactly what's happening. Imagine HR and engineering sharing all their traffic. Chaos, right? In this video, I'll show you how VLANs create private VIP sections in your network, boost security, and turbocharge performance. Stick around. Your switches are about to get way smarter.
To understand VLANs, it is important to have a good understanding of LAN networks. An LAN is a group of devices that share a broadcast domain that is common to them. When a device on the LAN sends broadcasts, everyone from the same local network receives them. We can say that an LAN is a broadcast domain. It's the same. Without VLAN, a switch considers that all its interfaces are in the same broadcast domain. This means that all connected devices are in the same LAN. With VLAN, a switch can put some of its interfaces in one broadcast domain and others in another. Each broadcast domain created by the switch is called a VLAN. So, to sum up, a VLAN is a virtual LAN. It's a broadcasting field, and it's also a logical network. VLANs meet three needs: segmentation, security, and network flexibility. They improve network performance by separating large broadcast domains into smaller segments. This gives the network administrator the ability to create small logical groups of devices. Even if these groups share the same infrastructure or the same switch, they act as an independent network. With a VLAN, you can do very well. For example, you can create groups of PCs by function, or in teams without worrying about the physical location of users. In addition, it is possible to assign certain restrictions only to groups of users. This adds to the security of the world. The switch ports, which are in the same VLAN, share the same broadcasts. You can't receive broadcasts from other VLAN. In fact, being able to contain broadcasts in the same VLAN improves the performance of the network. A VLAN may well exist on one or more switches, and PCs may well be in one or more buildings, and can also connect through the WAN. The process of transferring network traffic from one VLAN to another using a router is called inter-vlan routing. Each VLAN is associated with a subnetwork. This makes routing easier when there are several VLANs. To do this, you have to connect each VLAN to a router interface, and that way, the VLANs will be able to communicate with each other through the router, and without being polluted by the broadcasts of the other VLAN. In general, subnetworks are chosen based on the VLAN to which they are associated. For example, here VLAN 2 corresponds to the subnetwork 10.0.0.2.0, the VLAN 3 to network 10.0.0.3.0, and so on. Here we can see the third byte of the network, which identifies the VLAN to which it belongs. Now we'll see how to create a VLAN. The VLAN command in global configuration mode allows you to create a VLAN and go into its configuration mode. In the example, we create the VLAN2, which we call DRH. If you want to remove a VLAN, just make a no in front of the VLAN and its number. The VLAN1 is the default VLAN. VLAN are identified with a number between 1 and 1001. This is the normal range. Only VLAN from 1002 to 1005 are reserved for the token ring and FDDI protocols. The token ring is a technology based on the principle of communication in turn. That is to say that each PC must wait its turn to be able to speak. It loops from one PC to another to determine who has the right to transmit data. When the PC receives the token, it can start sending information for a period of time before handing the token back to the next PC. And the FDDI is also a token ring used on fiber optics, which can detect and correct errors. To return to the VLAN, the default VLAN and reserved VLAN are automatically created, and it is impossible to remove them. The configuration of the VLAN is written in a file on the switch called vlan.dat. This is the VLAN database that is stored in flash memory. To view the VLANs in this file, you have to do a show VLAN in the preferred mode of the iOS. When connecting a PC to the port of a switch, it must be associated with a VLAN. To do this, you have to assign the VLAN to the port of the switch. A port that is associated with a VLAN becomes an access port. The device configures command allows you to enter the overall configuration mode. Interface Fast Ethernet 0/5 command enters the configuration of this interface. The switch port mode access command allows you to set up the port in access mode. And the switch port access VLAN2 puts the port 0/5 in the VLAN2. When you create a VLAN, you have to assign the ports you want to put in this VLAN. A port can only belong to one VLAN at a time. By default, all ports are members of the VLAN1. The show VLAN brief command shows the VLAN's assignments at the switch port. For example, here we can see that the port FA 0/5 of the switch is part of the VLAN2, the one called DHR.